Good day, ladies and gentlemen. My name is Marcus Gelderneys, and I would be presenting my PhD work, which I am doing at the University of Wuppertal and also at Forschungszentrum Jülich in Germany. So with that, I would be presenting some of these gravity wave observations, which we did in 2016 during the Pulse Track campaign, where there was a complex dynamics of Rossby wave breaking. Here you can see we reconstructed the glory observations by limited angle tomography into a 3D field. And from this 3D field, we determined the 3D wave vector, which we can then plug into the Grograd ray tracer. This is one of these rays that you can see over here, and this is the horizontal cut, the ray traced right to this location. And this is the vertical cut. As you can see that the background is indicating very nice gravity waves, which is the ERA5 meridional residual wind component. The blue line is indicating the vertical wavelength, and the green line is indicating the Grograd calculated phase lines, which corresponds nicely to the ERA5 data, suggesting we can trust the ray trace. These black dashed areas is indicating when the cross-stream adjustrophic wind is greater than 7.5 meters per second, and this when it's greater than 10 meters per second. So it's just an indication how out of balance the jet is. And this gravity wave packet propagates above these areas of jet being out of balance and into this area where the jet is out of balance. And then we did some numerical experiments where we used the ESNWF IFS model run as a control run, and then used the very same dynamics and model parameters with the exception of using a smooth and flattened topography field of the T21 topographic spectral field. Here you can see in the control run that as we increase with time, the jet becomes more out of balance. And as we increase with time, there is a greater gravity wave field forming over Greenland. If we look at the T21 topography run, the jet is much more in balance. And if we progress with time and virtually no gravity wave field. So why does this happen? This is the control run minus the T21 topography zonal wind component along this red line over here. As the flow is then uplifted over Greenland, there's large changes in the zonal wind component up to well above the jet altitude. So with that, I'm concluding that the jet is heavily influenced by the topography, causing these gravity waves.